Hello, my name is Mrs. Smithy and I teach second grade at Stockwell Elementary. Welcome back to our virtual classroom. We are going to be doing a second grade math lesson today and we are on day 5. So the materials that you're going to need today are the day 5 worksheet and a pencil a little bit later. So go ahead and find those. We are going to start with some mindful breathing just to kind of get our mind and our body ready to learn our lesson today. So the mindful breathing exercise we're going to do today is called 5-finger breathing. And what you're going to do is you're going to use your hands and we're going to trace our fingers, and as we go up a finger we're going to inhale and breathe in through our nose, and then as we go down the other side we're going to exhale and we're going to breathe out through our mouth. Okay? So I'm going to show you what that's going to look like first. And breathe in as you go up. Hold it for a second. Breathe out. In. Hold it for a second. Breathe out through your mouth. In. Hold it for a second. Out. In. Out. In. And out. All right, pretty simple. This time I want you to try with me. Just pick one hand to use, and with your other finger you're going to trace your finger up and down along with me. And as you go up to the top of your finger, remember you're breathing in through your nose, and then as you go down the other side of your finger you're going to breathe out through your mouth. Okay, ready? Breathe in, out, in, out, in, out, in, out, in, out. That's a strategy you can always use because you have your hands with you most of the time. So anytime you need to take a minute to kind of calm down, take some breaths, those are one of our favorites in the classroom. All right. We are going to start with our target today. We are continuing to work with word problems, but we're going to be working with some larger numbers these next few days. We had only been working within 20, and now we're going to be learning some new strategies to compute those answers as those numbers get larger. So our target today is I can use addition within 100 to solve real-world problems. I can represent my answer using drawings and equations, and you'll be able to do this by finding information in a problem that's going to help you answer that math question. You're going to use a strategy, so we'll be focusing on 2 strategies you can use today, and then using evidence to provide or to prove your answer. So again, making sure we have an equation, a drawing, some way to show your thinking when you're solving these problems. All right, so the question we're going to start with today is what strategies can I use to add larger numbers? We're going to be working with addition today, so that means we're going to have our parts and we're going to be missing our whole. So this is our bar model, or our part-whole model that you may call it. And we have a problem down here that has a part of 46 and a part of 23, but we're missing the whole. So we've talked about before how you add the part plus the part, and that's going to get us the whole. So we're going to do that today. We're going to be solving 46 plus 23, and that's going to get us our total. So I'm going to go ahead and write our equation up here. 46 plus 23 equals, and I'm going to put a question mark there because we don't know our whole yet. I'm also going to write that equation down here because we're going to solve the same problem using 2 different strategies. Does that mean our answer should be the same? Yes, the whole is going to be the same. The way we are finding that whole may be different. So our strategies may look different, but our answer should match. So the first strategy we're going to talk about is base 10 models. And you may have used these before where you draw a line or a rod, and that is worth 10. And you make a little circle that could be called a unit, and that's worth 1. So we're going to show 46 plus 23 by drawing those models. So for 46, I'm going to draw 40. And to do that, I'm going to draw 10, 20, 30, 40. I'm going to draw my ones, 6 ones. I'm just going to do 1, 2, 3, 4, 5, 6. So we have the number 46. We're going to add 23 to that, so we are going to draw 23 here, 10, 20, and then 3 ones. Now I like to draw my 10s together and my ones together because when we combine them, when we add them, it's going to be easier to see them in groups. So now we're going to find the total number. So we're going to count our ones, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 ones, and then we're going to count our 10s that we have together. 10, 20, 30, 40, 50, 60. That's 6 10s, 9 ones, and our answer is 69. Let's see if we get that same answer using another strategy. This strategy is called expanded form, and we're going to decompose these larger numbers into the 10s and 1s. So if you take 46 and this is in standard form right now, and you break it apart and you put it in expanded form, it's going to look like 40 plus 6. So I'm going to write that out, 40 plus 6. Then we're going to decompose 23. We're going to break it into expanded form. That would be 20 plus 3. So I have our 10s and I have our 1s. Now, all I need to do is add the ones that we have. So we have 6 ones plus 3 ones. That would give us 9 ones. 40 plus 20, or 2 more 10s. That would be 50, 60. Now we have to squish it back together into standard form. So 60 plus 9 is the same as 69. I know that I did my problem correctly because our answers match. Those are 2 strategies you can use when adding larger numbers. Let's try one more. So again, we have our parts 67, 18. We know that the equation that we need to create from that bar model is what? 67 plus 18 equals question mark. That's going to give us our whole. So using base 10 models, I want you to think, what are we going to draw to represent 67? Six 10s, 7 1s, plus our 18, that's 1 10 and 8 1s. Now we're going to combine them all together. I'm going to change my color so you can kind of see where I draw my circle at, because I see I've got more than 10 ones, and I can make a new group of 10. So I can put 10 of those ones together and make a rod. We're just going to trade it. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here is a group of 10. I'm going to trade that for a new 10. I just moved it. I didn't change the amount. I just put them together and moved it. So now I can count my ones. 1, 2, 3, 4, 5. And I can count my 10s. 1, 2, 3, 4, 5, 6, 7, 8 10s. That would be 85. Let's see if we get the same answer using the expanded form. Okay? So again, we're going to break 67 into expanded form. What would that be? 67 broken into 10s and 1s. 60 plus 7. What about 18? If we're going to change 18 to expanded form and break it apart, there's 1 10 and there's 8 1s inside of 18. Now we have 7 1s and 8 1s, and I know that 7 plus 8 is a doubles plus 1. 7 plus 7 is 14, So one more from that 8 would give us 15. And 60 plus 10 is 70. Now you may know 70 plus 15 in your head, but for me it's a little bit easier if I go ahead and decompose this 15 again into 70 plus 10 plus 5. Because now I can easily see 70 plus 10 would be 80, plus 5 more is 85. You can move those numbers around however it is that makes it easiest for you. Again, we have our same answer, so I know we probably have the correct whole. All right, we're going to watch another Learn Zillion video, and as we watch this today, I want you to be thinking which strategy would be easier for you. You really want to see which strategy works best for you and what you understand.
How do you know how many magnets there are? In this lesson, you will learn how to solve word problems by making an easier problem. Let's review. When we add, we can group numbers in different ways. We have 4 plus 4 plus 1. We can add the 4 plus 4 first, which gives us 8, and then the 1. Or we could add the 4 plus 1 first, which is 5. We'd have 4 plus 5. They both get the same solution of 9. A common misunderstanding is thinking that the 6 in 68 has a value of 6 instead of 60. 6 is in the tens place, so it has a value of 60, not 6. And 8 is in the ones place, so it has a value of 8. How many magnets are in that pile? The magnet room at the Children's Museum has a structure with 37 ball magnets and 45 rod magnets. How many magnets are there altogether? There's 37 ball magnets and 45 rod magnets. So I need to use addition to solve the problem. I know part of the pile is 37 ball magnets, and part is 45 rod magnets. So what is the whole? I need to add them together. I can make that problem easier by using place value. I know that 37 is 30 plus 7, and 45 is 40 plus 5, because that's how many tens and ones that I have. Now if I add the tens together, 30 plus 40 equals 70, and the ones, 7 plus 5 equals 12, it's easier to add 70 plus 12 and get 82. We can work with those numbers to make the problem easier. Zim says, I played with the magnets. They look different, Zim. Then I played with the numbers to make the problem easier. I can make place value blocks or draw them to show my numbers. I have 40 and 5 and 30 and 7. What if I put that 5 and that 5 together? I get another 10. It's easier to add. 40 plus 10 plus 30 plus the last 2. That's 82. Which problem would be easier for you, Zim's or Ian's? How did you know how many magnets there were? We both made easier problems. There were 82 magnets. In this lesson, you have learned how to solve word problems by making an easier problem.
Okay, so for this next part, you are going to need your worksheet that should be in your packet and a pencil so you can work these problems along with me. Now that we've learned a few strategies to help us compute, that just means solve those addition and subtraction problems, we're going to see how we can use those in a word problem, okay? So we're going to read the word problem through one time, and then we're going to chunk it just like we've been doing. And then we have a box for our evidence where we're going to draw our model and our equation, and we probably are going to need to use one of those strategies we've learned to work with those bigger numbers. And then we are going to write our complete answer with a label and then check if it's reasonable again at the end. So our first word problem today says, the Lego room at the Children's Museum has a structure with 53 red bricks and 24 black bricks. How many red and black bricks are there in all? So I'm going to start by finding that question that they're asking us. Do you see where the question is in that problem? Hint, usually there's a question mark at the end. How many red and black bricks are there in all? So are we missing our whole, or are we missing a part here? We're missing the whole. We need to know how many there are all together. So I'm going to go ahead and I'm going to draw my model here. And I know that I'm missing my whole. I'm just going to put an X there. Same thing as putting a question mark. It just means it's missing, and that's what we're finding, okay? Don't let letters confuse you in math. If you see letters, usually it's just because we don't know what that number is yet. So I know that part of the bricks, let's start from the beginning and read. The Lego room at the Children's Museum has a structure with 53 bricks. Let's go ahead and stop there. So we know part is going to have 53. And 24 black bricks. So the other part is 24. We can create an equation from our part-whole model here. What equation do you think we could write down? We know that when we add our parts together, we can get the whole. Do we know our whole yet? No, so I'm just going to put X there. We're going to find out what X is, okay? Now 53 and 24, those are some larger numbers. What strategy could we use that we just talked about to add those numbers together? Well, I'm going to go ahead and use my base 10 models. If we're going to draw 53, we would draw 5 rods, those are worth 10, and 3 units, those are worth 1. We're going to add 24, so that stands for 20, and 4 more ones, okay? On your paper, I want you to go ahead and write the model, just like I've done. Make sure you have your equation there. I want you to try the base 10 models. What did you get for the total? Add all those ones together, add all those 10s together. 1, 2, 3, 4, 5, 6, 7 ones. And how many 10s are there? 1, 2, 3, 4, 5, 6, 7 10s. That would be 77. So that means X should equal 77. Let's use that expanded form too, where we break the numbers apart into 10s and 1s. If we're looking at that same equation, 53 plus 24 equals X. If I break 53 into expanded form, what would that be? 50 plus 3. What would 24 be? 20 plus 4. Now we have 3 1s and 4 1s, and we have 50 and 20. Those are our 10s. If we add those together, what answer did you get? Three 1s and 4 1s is 7 1s. 50 plus 20 is 70. So I know that's 7 10s and 7 1s Our answer is 77. We got the same answer using both strategies, so I am very confident that's the correct answer. 77, what's missing in our answer here? Our label, right? What are we talking about in this problem? We're talking about bricks, red bricks and black bricks. So I'm going to put 77 bricks. Just to check, is this answer reasonable? Let's plug that in and see. If we had about 50 for one part and about 25 for this part, 50 and 25. Well, I know when I count quarters using money, 50 plus another 25 would give me 75. So our answer should be about 75. Was our answer pretty close to that? Yeah, 77 is pretty close. So I would say this is a reasonable answer. Now, if we would have gotten an answer that would be less than one of the parts, for example, what if we got 30 for our answer? Well, if we're starting with 53 bricks and 24 bricks, would it make sense that in all there was 30? No, so just go back and check and make sure our answer fits when you get done solving a problem. All right, we are going to do one more together today. We have a new problem. We're still talking about the museum, but we're going to go ahead and read through the problem, and when I get done reading, I want you to break it apart and go ahead and create a bar model or create your part-whole model, and then use that model to create your equation. I would like you to stop there at the equation. We'll check and make sure our equation is correct, and then we'll go on to finding our answer. Okay? The magnet room at the Children's Museum has a structure with 48 ball magnets and 26 rod magnets. How many magnets are there all together? The magnet room at the Children's Museum has a structure with 48 ball magnets and 26 rod magnets. How many magnets are there all together? Go ahead and draw your part-whole model or your bar model. And then use what you created from your model to create an equation to solve the problem. All right, so what was the question they were asking us here? How many magnets are there all together? So what are we missing? Are we missing a part or are we missing the whole here? Yeah, all together, we want to know how many ball magnets and rod magnets there are. So I'm going to put an X here again. We don't know what that whole is yet. What part do we know? There's 48 ball magnets, so you should have a part that's 48. And 26 rod magnets. So your other part should be 26. If you created your equation that would match this model, it would be the part 48 plus the part 26 equals X. We don't know yet. Okay? If you did not have your equation written correctly, that's okay. Just fix it. Now, are we done? No, we still haven't answered the question yet. Now we need to compute our answer. Okay, so we're going to use addition. I want you to use a strategy. Try to use the base 10 model, the expanded form. Maybe your teacher this year taught you a different strategy to use. You can use that. That's evidence. And explain your thinking. I'm going to give you about 30 seconds to work on that and get your answer. Okay. Well, I'm going to show you the base 10 model first. If you use the base 10 model, it should look something like this. If you drew 48, then you should have 4 10s, 10, 20, 30, 40, and 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. You should also have 26 that you're going to add to that. I'm going to go ahead and add my 10s to this side. 10, 20 for 26, and then I need 6 more ones. 1, 2, 3, 4, 5, 6. Now I need to find all of my ones that I have, and I can look at my dots right there, my ones, and see I think I may have more than 10. If you noticed, I kind of started to draw them in an array like we talked about a few weeks ago. That way it makes it easier for me to add and they stay organized. If you're using base 10 models, it's important that you draw nice and neatly and that you stay organized because you don't want to make a mistake because you have a sloppy drawing. All right, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did you get a group of 10 with yours? You should have. I can trade that out and move it over here to the 10s. Just going to trade it, I'm going to put them all together and make a 10. Now I have 4 ones that are left. So I have 4 ones. And then how many 10s do we have in all now? 10, 20, 30, 40, 50, 60, and we need to count that 10 that we moved over there. So we've got 1, 2, 3, 4, 5, 6, 7, 10s. So 74 is the answer I got using that strategy. Let's quickly use expanded form to solve the same problem. If you used expanded form, if that strategy made more sense to you, it should look like this. 40 plus 8, that's 48 in expanded form, plus 20 plus 6, because 26 has 2 10s and 6 ones. 8 ones and 6 ones would be 14. 40 plus 20 would be 60. And this part I kind of do in my head. That 14, I don't know what 14 plus 60 is, but I do know 14 is 10 plus 4. So I'm going to take my 60, go ahead and add the 10, that would be 70, and then I have my 4, 74. Is that the same answer we got using base 10 models? Yes. So 74, what's our label that's going to go with our problem? Magnets, right? Let's plug this in and see if this is a reasonable answer. 48 is about 50. 26 is about 30. I know 50 plus 3 more 10s is 80, so our answer should be close to 80. 74 is pretty close. I think this is definitely a reasonable answer. All right, you have one more on your page, and that is going to be our extension today. So I want you to read the problem, make sure you show all of your evidence, have a complete answer, and check if it's reasonable. Thanks for your hard work today, guys. I will see you next time.